7258, two-cycle engine thrust and fuel efficiency can be greatly compromised when A. Exhaust systems are installed that are not specifically tuned for an engine. B. Carbon deposits build up on exhaust valves. C. Intake valve lifters fail to pressurize and provide adequate fuel to the combustion chamber. The correct answer is A. Exhaust systems play a crucial role in the performance of an engine by helping to evacuate the combustion gases from the cylinders. They are designed to optimize the flow of exhaust gases, taking into account factors such as back pressure and resonance. When an exhaust system is not specifically tuned for an engine, it may result in poor exhaust gas flow, leading to several issues that can impact engine performance. One of the main problems that can occur is increased back pressure in the exhaust system. Back pressure is the resistance encountered by the exhaust gases as they try to exit the engine. When back pressure is higher than optimal, it can restrict the efficient flow of exhaust gases, leading to reduced engine power and compromised thrust. This can negatively affect the overall performance of the engine, especially in terms of acceleration and top speed. Moreover, improper tuning of the exhaust system can also result in poor scavenging. Scavenging is the process by which the outgoing exhaust gases help to draw in the fresh air-fuel mixture into the combustion chamber. When the exhaust system is not properly tuned, it can disrupt the scavenging process, reducing the efficiency of the engine's intake cycle. This can lead to incomplete combustion and decreased fuel efficiency. In addition to the direct impact on engine performance, an exhaust system that is not specifically tuned for the engine can also contribute to increased engine operating temperatures. Higher temperatures can accelerate the degradation of engine components, such as seals and gaskets, and can also increase the likelihood of detonation or pre-ignition, which can cause engine damage. Overall, installing exhaust systems that are not specifically tuned for a 7258.2 cycle engine can result in increased back pressure, poor scavenging, reduced engine power, compromised thrust, decreased fuel efficiency, higher operating temperatures, and potential engine damage. 7260. A typical two-cycle engine ignition coil is powered by A. A battery, B. A battery or an alternator, C. A magneto. The correct answer is C. In a two-cycle engine, the ignition coil is responsible for generating the high-voltage electrical spark that ignites the air-fuel mixture in the combustion chamber. This spark is crucial for initiating the combustion process and powering the engine. The ignition coil consists of two primary components, a primary winding and a secondary winding. The primary winding is connected to a low-voltage power source, which is typically a magneto in a two-cycle engine. A magneto is a self-contained electrical generator that generates electrical energy without the need for an external power source, such as a battery or an alternator. It utilizes a rotating magnet or magnets to produce a magnetic field, which induces an electrical current in the coil windings. The magneto generates a high voltage in the primary winding of the ignition coil, typically in the range of several thousand volts. When the primary winding of the ignition coil is energized by the high voltage from the magneto, it creates a magnetic field around the secondary winding. This magnetic field buildup continues until the ignition coil reaches its saturation point. Once the magnetic field in the primary winding collapses, it induces a high voltage in the secondary winding of the ignition coil. This high voltage is then delivered to the spark plug through the ignition system, resulting in a spark that ignites the compressed air-fuel mixture in the combustion chamber. The use of a magneto to power the ignition coil in a two-cycle engine has several advantages. It eliminates the need for an external power source, such as a battery or an alternator, making the ignition system self-sufficient and independent of the engine's electrical system. This simplifies the engine design and ensures reliable ignition even in remote or off-grid applications where a battery or alternator may not be readily available. 7261. Many forced-cycle engines utilize what type of lubrication system? A. Forced, B. Gravity, C. Fuel/oil mixture. The correct answer is A. In a four-cycle engine, lubrication is essential to reduce friction between moving parts, prevent excessive wear, and ensure proper functioning of the engine. The lubrication system delivers oil to various engine components, such as the crankshaft, bearings, pistons, and camshaft, to keep them well lubricated and protected. A forced lubrication system uses a pump to circulate the oil throughout the engine. The pump is typically driven by the engine's rotating crankshaft or camshaft. It draws oil from the oil pan or sump and pressurizes it before distributing it to the engine's critical parts. The pressurized oil is directed through a network of passages and channels to reach the various lubrication points. The oil is delivered under pressure to the main and connecting rod bearings, camshaft bearings, and other components that require lubrication. It forms a thin film of oil between the moving parts, reducing friction and heat generation. After lubricating the engine components, the oil drains back into the oil pan or sump, where it is collected and recirculated by the pump. The process of forced lubrication ensures a continuous supply of oil to the engine, even under varying engine speeds and loads. Forced lubrication systems offer several advantages over other lubrication methods. By using a pump to circulate the oil, they can deliver a consistent and controlled amount of lubrication to critical engine parts, ensuring optimal lubrication even under demanding operating conditions. They also enable the use of an oil filter, which helps remove contaminants and debris from the oil, further enhancing engine protection. In contrast, gravity lubrication systems rely on the natural flow of oil due to gravity to lubricate the engine. However, gravity lubrication is typically insufficient for four-cycle engines, as it may not provide adequate oil pressure and distribution to all the necessary components. Fuel/oil mixture lubrication, also known as premix lubrication, is commonly used in two-cycle engines where the oil is mixed directly with the fuel. This mixture is then combusted in the engine, and the burning oil provides lubrication to the internal components. However, this method is not typically used in four-cycle engines. 7262. Adding more oil to the fuel than specified by the manufacturer of a two-cycle engine will result in A. Increased engine performance. B. Increased carbon buildup and engine fouling. C. Increased engine lubrication and optimal performance. The correct answer is B. In a two-cycle engine, the oil is mixed with the fuel to provide lubrication to the engine's internal components. This oil-fuel mixture is crucial for proper lubrication and cooling, as there is no separate oil system in a two-cycle engine. The manufacturer of a two-cycle engine specifies the correct oil-to-fuel ratio that should be used for optimal performance and engine longevity. This ratio is typically expressed as a ratio of oil to fuel, such as 150 or 140, indicating the amount of oil that should be mixed with a specific volume of fuel. Adding more oil to the fuel than specified by the manufacturer is commonly referred to as running a rich mixture. While it may seem like adding extra oil would provide better lubrication and protection, it can actually lead to negative consequences. When the oil-to-fuel ratio is increased beyond the manufacturer's recommendation, several issues can arise. One of the main problems is increased carbon buildup. The excess oil does not burn completely during combustion and can leave behind deposits on various engine components, including the spark plug, exhaust ports, and exhaust system. These carbon deposits can restrict airflow, reduce engine efficiency, and cause engine fouling. Engine fouling refers to the accumulation of deposits that can clog or hinder the proper functioning of engine parts, leading to decreased performance and potential damage. Moreover, running a rich mixture can also lead to incomplete combustion. The excess oil can interfere with the combustion process, resulting in reduced power output and increased exhaust emissions. It can also cause spark plug fouling, misfiring, and poor engine response. It is important to follow the manufacturer's recommended oil-to-fuel ratio for a two-cycle engine to ensure proper lubrication, cooling, and combustion. Deviating from the specified ratio by adding more oil can have detrimental effects on the engine's performance and longevity, including increased carbon buildup and engine fouling. 7259. The purpose of a kill switch is to A. Shut off the fuel to the carburetor. B. Ground the lead wire to the ignition coil, shutting down the power plant. C. Ground the battery, eliminating current for the ignition system. The correct answer is B. In an engine's ignition system, the ignition coil plays a crucial role in generating the high-voltage spark that ignites the air-fuel mixture in the combustion chamber. The ignition coil is powered by the battery or electrical system of the engine. A kill switch is a device or mechanism designed to quickly and effectively shut down the engine or power source. When the kill switch is activated, it grounds the lead wire connected to the ignition coil, effectively interrupting the flow of electrical current to the ignition coil. By grounding the lead wire to the ignition coil, the kill switch prevents the ignition coil from producing the high-voltage spark necessary for combustion. As a result, the engine's power plant is shut down and the engine comes to a stop. The grounding action of the kill switch creates an electrical circuit that diverts the current away from the ignition coil and prevents it from generating the spark. This ensures that the engine cannot start or continue running as long as the kill switch is engaged. The purpose of the kill switch is to provide a quick and reliable method for stopping the engine in case of an emergency or when immediate shutdown is necessary. It is commonly used in various applications, such as automotive vehicles, motorcycles, boats, and power equipment, to provide a safety mechanism that can swiftly disable the engine in potentially hazardous situations.